Alright, let's look at the homework 1.2, 1.3, problem number 8. Alright, so we have this differential equation dv over dt. So this is actually a derivative of a velocity and is equal to 32 minus 1.6 v. And 32, this is just acceleration by gravity. And you can see that this part is you can think of it as a resistance. All right, so but anyway, so we want to sketch the slope field for part A, so we know how to do that, right? So we can just define f of x comma y is going to be colon equal to, all right, I'm going to use y for v and x for t. All right, so you have a 32 minus 1.6 v, so I'm going to use y. All right, then hit enter. All right, now we have f of x. All right, then we want to plot the slope field. So you have a slope field, and put f in there and hit enter. All right, so we have that. Alright, and to make it look a little bit better, I'm going to just use this to rescale things. And I'm going to actually just rescale the y-axis a little bit, and so that you can see a little bit better. And I'm going to probably stitch out a little bit. Alright, so here. Alright, so it looks like this. Alright, so this is the velocity of object falling down through a certain medium, and we're looking for part B, the limiting velocity. All right, what happens to the derivative of the velocity when it's getting closer to the limiting velocity? All right, limiting velocity, and you can see that it's going to be around here. Maybe I can draw a picture here. Right, so it's going to be around here. Right, you can see that the velocity kind of stabilizes, right? And so that's going to be the limiting velocity. And what happens to the derivative would be, you can see that here all these tick marks are all horizontal. So the derivative is going to be equal to 0. So in order to find that, all you have to do is take the differential equation. So you have a derivative is dv over dt, and which is given to be 32 minus 1.6v. Right, and we set that equal to 0 because at the limiting velocity, the rate of change is 0. All right, so if you solve that, right, so we're going to subtract the 32 from both sides, so negative 1.6v is equal to negative 32, and you can just simply divide it through by negative 1.6. So this is going to be v is equal to, that's going to be negative is positive, right? So 32 divided by 1.6 is actually 20. All right, so the limiting velocity is actually 20. All right, so let's see. I'm going to actually try to get rid of that. Let's see, maybe I can go here. All right, if you click on this the drawing and highlight it and hit delete, so it's gone now. All right, so we have that, and then what we want to do is we want to let's see. We want to know how long it takes to hit 95% of the limiting velocity. All right, so first I'm going to try to sketch the solution curve. All right, so solve ODE. All right, then F, and we know that it has to go through 0, 0. So the origin 0, 0, and hit enter. All right, so you can see that this is a solution curve. All right, then what we want to do is we want to hit the 95% of the limiting velocity. So I'm going to say y is equal to 95%, so it's going to be 0.95 times limiting velocity, in this case is 20. So hit enter, right? So which is 19. So what we want to do is we want to see when this solution curve is going to hit 19, right? So we're looking for this intersection. So there's a great tool. So we can go to here, right? Then it said intersect. So we want the intersection between this curve. So click on that. And also this horizontal line, click on that. Then you can see that this is the point here, right? And if you want to see where the point is, we're going to actually need the algebra window. So I'm going to open up the algebra window, all right? And I can actually get rid of that too, all right? So, and let's see, I'm going to just get rid of this, delete that. All right, so you can see that this is point A is the intersection point. And the intersection point is 1.87, 19, which means that it's when t is equal to 1.87, the velocity reaches the 95% of the limiting velocity, right? So that's why we have 1.87 seconds approximately, right? And that's it. I hope that this was clear.